Let's now have a look at some so-called sex-linked conditions. In this case, specifically sex-linked recessive conditions. What is sex linkage? An allele is sex-linked when it is located on a sex chromosome, which is usually the X chromosome. Over here I have an example of the X chromosome. And the locus of a gene is its place of the gene on the chromosome. So if a certain gene is found on the X chromosome, then it is considered to be sex-linked. It is also possible that there is sex linkage in relation to Y chromosomes, but this is rather rare because the Y chromosome is quite small and the X chromosome is so much bigger. There are many more genes which can be found on the X chromosome. Therefore, there are also many more conditions and diseases which can be passed on over the X chromosomes. And what I have over here is a list. This one is from a screenshot from Wikipedia. Some examples of most common sex X-linked recessive disorders, and red-green color blindness is one example, and then there are even two forms of hemophilia. In this case, in hemophilia, the blood is not able to clot because a clotting factor is missing. And this can also be inherited, and I'm going to do a few of these. I'm going to do some crosses involving an example of red-green color blindness and also hemophilia. So, but let's move on. Let's do these crosses. Let's have a look at color blindness. Because it is sex-linked, we have to use a different writing system. We have to use the letter X here for the X chromosome, and then we write the allele in the form of a superscript. So X capital B is the normal allele. This means the non-colorblind allele, and the lowercase b is the allele for colorblindness. I know what you're thinking, theory of knowledge, what is normal, and so on. I know, don't get me started on this. If you do not like the word normal, then you can actually say the non-affected allele. Over here, our problem situation is the following. A colorblind father has children with a mother of a normal vision. The mother's father had normal vision, but the mother was colorblind. How do the children look like? Well, because it is sex-linked, we have to worry about the XY writing. So I'm going to write over here an X and a Y for the father, because men have XY chromosomes. The father is colorblind. So I'm going to write a lowercase b over here, next to the X chromosome. There is nothing over here on the Y chromosome because the allele can only be found on the X chromosome. So there's nothing over here. And the mother had a normal vision. So this means that the mother must have at least one capital B. But we don't know about this one yet, so we need to continue reading. The mother's father had normal vision, but the mother was colorblind. So in this case, we have to look at this woman's parents. Over here, the mother was colorblind. This can only be if she is homozygous recessive, colorblind. And the father had normal vision. And if the father had normal vision, he must have had over here a dominant normal allele. And if we look at this, then we can already quickly see that this woman over here must have inherited this X chromosome over here from the father. And the mother is only able to give a recessive allele because she only has two lowercase b's, two color blind alleles. So over here there must be also a lowercase a recessive allele. It's either one of these two, it doesn't matter, must have been passed on to this woman over here. And now we have the parents over here, and now we can do a cross with them. So over here I have the colorblind father. Over here, the mother who has a normal vision, capital B, lowercase b, and then now let's see what we get. We get X, capital B, X, lowercase b, X, lowercase b, X, lowercase b, X, Y, over here's a capital B, and then X, lowercase b, Y. As expected, two girls, two boys. Now what is the genotype ratio? Now that is a lot of writing. I don't know if I'm going to do this now. 1X, capital B, X, lowercase b, 1x lowercase b to 1x capital B y, 1x lowercase b to y. So it's a 1 to 1 to 1 to 1 genotype ratio. The phenotype ratio would be is that you have one girl which is not affected, one girl who is affected, who has color blindness, one boy who is not affected, and one boy who is colorblind. So as you can see, half of the children in this case are colorblind and half of the children are normal. Again, you write this out yourself. I would like to move on, and I would like to give you now the next example. Let's have a look at hemophilia. Hemophilia is an illness where the blood does not clot. And over here I have again defined my alleles. X capital H is the normal or the unaffected allele, and X lowercase h is the allele for hemophilia. An unaffected father has children with a mother who is a carrier. Now, if the mother is a carrier, important word, I made it yellow over here, then she herself is not affected, but does carry the affected allele. So carriers, okay, in this case are heterozygous, not only in relation to sex linkage, but right now I'm simply using this as an example. So both parents do not have hemophilia, are not affected, are healthy. But let's have a look at the children. A girl and this girl, two capital H's, not affected. One girl, another girl, not affected. There's a capital H over here. She is healthy, does not have hemophilia, but she, just like her mother, is a carrier. And over here, a boy, not affected. And over here, a boy who is affected. Because there is no capital H present over here, because boys do not have two X chromosomes. There's a Y chromosome over here. There is no capital H on the Y chromosome. There's only a defective lowercase h, defective gene. So the blood clotting factor cannot be made. And if you look here, as you can see that 50% of the boys are affected. So the genotype is just as before. It's a 1 to 1 to 1 to ratio. And the phenotype is the following, is that 50% of the boys are affected or have hemophilia, but none of the girls. So, and over here again, the genotype ratio is a 1 to 1 to 1 to 1 ratio. So again, very interesting. Conditions which are inherited over the mother. And the father, if the father had hemophilia in the 19th century, this would have meant that he would not have, there were rarely fathers who had that because they wouldn't survive that long. Many of them died when they were even before puberty, because even small injuries were deadly, because the bleeding would not stop. So these were now two examples in relation to sex-linked recessive conditions.